All right, as we start to get into our major thesis, I just want to kind of talk about a couple different types of statistical tests that you can run on your data versus the one we know right now, the Pearson's Row, where you're trying to find if there is a significant relationship between two quantitative variables. But a lot of times we don't want to see if there's a relationship. We want to do more comparative tests. So I'm going to run through a couple different of the most common tests that we do in Zoo School projects. And if you think one of yours will apply to that, that's great. If you feel that none of these really work for you, obviously let me know and we'll look at that together. So again, there are lots and lots of different statistical tests, and I'm just going to try to tell you a little bit about each one, and then I'm going to show you how to write our null and alternative hypotheses for each. And the important part of that, obviously, that's the first thing you do the last thing you do in chapter 2. So that's the first kind of statistical thing that you'll have in your major thesis, is these kind of pairs of hypotheses. So I just want to kind of show you what those look like. So the first one is when we're trying to compare a single mean versus a known value. Now, most of these will talk about means. There are also tests for proportions. So if you want to know the percentage of time, if you want to compare it to a known value, that's fine. But typically in Zoo School, most of our tests are going to be done on means or averages. So you can do a test of a single mean versus a known value. Now, this is not very often done, and the reason is we're trying to test if a single mean is significantly different from a known value. The problem with this kind of test is you have to know kind of a traditional value or some historical data or something about your individual animal. So we might say, all right, a keeper knows that the average time for the polar bear to eat a meal is 35 minutes. Okay? Well, that's something they would have to provide you. Now, if they provided you with that, that's great, and you'd have something like that. And so if you know a traditional value and you feel like you change something, a new type of food or a new way to feed them, you're going to think that that's going to change the time it takes for the polar bear to eat. And when I say change can mean lots of things. You could think that it's going to increase, that it's going to take longer to eat the new food. You could think that it's going to be less time to eat the new food than the traditional value. Or we could just use the statement of inequality, saying, I don't know if it's going to be larger or smaller, but I think it's going to make a difference. I think it is going to be different from what we've seen in the past. So these are the kind of things that we do if you had this single value. Now, if you have value, that's great. This would be kind of how the hypotheses would be written. So what I'm going to do is I am going to define what my mean is. Now, if you remember, mu is a population mean. So this would be the average time they spend eating, at all the times. So it's always important, and we'll talk more about this in chapter 3, you want to define what your means are. So in this case, I'm letting mu1 represent the average time for the polar bear to eat their food. And so the null and alternative hypotheses, just like a Pearson's Row, will show that there is not a difference or there is a difference. Just like there was not a relationship or there is a relationship. So the null hypothesis is going to look something like this. There's not a significant difference, and that's very important. We're talking about differences here. And it's a difference because we're trying to say that it is either going to be the same as it's always been, it's always been 35, it still is, or it's going to be different. So in this case, I'm going to say there's not a significant difference between the mean time the polar bear and their scientific name eats their food compared to the stated value at the Columbus Zoo and Aquarium. Now again, the hard part about it is this stated value. That's the tricky thing. And so you can see here the mathematical way we will say this is we'll say h sub 0, the null, is that the mean is the same as 35. Because saying they're not different, they're basically the same. So the alternative is saying there is a significant difference between the mean time they eat their food compared to the stated value at Columbus Zoo and Aquarium. And so in this case, I said H1. You could also say this is HA. Either way is fine. So the alternative hypothesis is that mean is not 35. And this is just saying there's difference. You could also, if I were to say there's a significantly larger difference, Then I can say it's greater than if I think it's more than 35, or I can say it's less than 35 if it takes less time. A lot of times in studies we will do the not equals just to see if there's a difference, and then obviously if the mean was bigger than 35, then it's significantly bigger. So a lot of times we'll do these not equals, and some tests that's the only thing you have an option for. So that's comparing one mean, a single attribute, to a known value. So we already talked about you can ask if the mean is greater than less than, and again just change that sign. Nothing really different. So the second test we're going to talk about is the difference between two means, and this is the one that is done fairly regularly. This is a pretty straightforward test. What it does is it compares if there's a significant difference between two population means. So if you think about two things about your animal, maybe with something or without something, then this would be a good test to use. An example would be if a keeper was wondering if a turtle was more active with enrichment versus without enrichment. So anytime you're comparing two things with, without, this half of an exhibit, the other half of an exhibit, do they perform more natural or stereotypic behaviors, anything like that, a difference in means is a good way to go. So in this case, we have two means. In the last one, we're just comparing one mean to a known value. In this case, we really don't know any of the means. So I am going to represent the first mean be the average time that the turtle is active with enrichment, and the second one would be the average time that a turtle is active without enrichment. So one is with, one is without. So again, the null is always going to say they're basically not a difference between their two. So the null states there is not a significant relation or significant difference, don't say relationship, a significant difference in the mean time that the turtle spends active with or without enrichment at the Columbus Zoo and Aquarium. So we're saying there basically is no difference. Also, I should mention, don't write CZA, actually write it out when you write this in your study. So there's not a difference between the two. So the null is saying that the first mean and the second mean are basically the same. The two average of those are not significantly different. And the big thing is significantly different. They might be slightly different, but that difference might just be to random chance. There is not a difference that is not due to chance. The alternative, of course, is just going to say there is a significant difference in the mean that the turtle spends active with or without enrichment. And again, this statement's not really saying which one is larger, it's just saying that they're different. So if you show that there is a difference and then one is bigger than the other, you can talk a lot about how that one is significantly more. In very rare cases, the study is one directional, like sometimes they only want to know if they are more active with enrichment. They don't care if they're less active. So in that case, you might say, I only care, the only thing I'm testing for is if the with enrichment is bigger than the without enrichment. That would be another way to go. But it might actually be telling that what does it mean if they're less active with enrichment? And if you test this way, you really don't prove that. Or what if they're more active without enrichment? You're not really talking about that in this case. That's why we typically do the two-sided, because it takes both directions into account. The final test we'll talk about is the ANOVA. Now, an ANOVA test, ANOVA is short for analysis of variance. So ANOVA is kind of like a difference of means test. Just what it does, though, it compares if there's a significant difference in one population mean when there are three or more means being compared. So in a difference of means, you only have the two groups, the first group and second group. For an ANOVA, you can have three or more. You can have infinitely many. I would warn you that it is generally a rule in zoo school that we do not test more than 5 means, because the initial test is not very difficult, it's not very lengthy, but when you reject an ANOVA test, there are follow-up tests, and that can be, the more means you have, the larger that test becomes. So an example of an ANOVA test would be in an exhibit study where we want to see if a keeper was interested in which area of an exhibit the lion uses the most. So if you take a lion exhibit and you break it into a couple different sections, 1, 2, or 3, they want to know if they spend significantly more time in one of those sections, then that would be an idea for this test. Behavior studies, if you have several behaviors, So our tree kangaroo can either be escaping or eating or sleeping. And you could see if they do one of these behaviors significantly more than the other. So that's the idea of an ANOVA, plus the follow-up to the ANOVA. So that is another idea for you. A lot of people do ANOVAs because difference in means kind of limited to 2 things, and typically you have 3 or more. So for an ANOVA, we have to define lots and lots of means, right? So I'm going to let mu1, mu2, mu3, blah, 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 represent the average time spent in the different zones of the lion exhibit, or the different behaviors, or whatever. So when you define these, now you might define them in chapter 3, you might define them in chapter 2, but somewhere you need to tell the reader what these means are. So the null is going to say there's not a significant difference in the mean amount of time the lion spends in any zone, and this is the key word for ANOVA, null. We think they're basically all the same. So the null is going to say that the first mean is basically the same as the second mean, the third mean, all the way to however many means you have. Okay. Again, let's not try to go over 5. 3 or 4 is even better. The alternative is going to say there is a significant difference in the mean amount of time the lion spends in at least one zone. So what they're going to say is, all right, we have this exhibit broken into lots of parts. I think they're going to spend a significantly more amount of time, or less time, honestly, in one zone of their exhibit. So you might find in this exhibit, we'll try to draw the same one, we might show, hey, they spent a lot more time in 1 than 2 or 3. An ANOVA could also show that they spent a lot less time in 3 than the other 2, but they really don't prefer 1 or 2 to the other. It could be a hierarchy. It could say they like this one the best, this one the second best, this one the third best. It could say they're all about the same. So there are lots and lots of different results you can get from an ANOVA, and we'll talk about how to interpret those results later on. So the mathematical hypothesis for an ANOVA test, there's actually no mathematical symbols. We actually just write H1 or HA, at least one mean is different. So if you're doing an alternative hypothesis for an ANOVA test, then you just have to write it kind of like this with the words. We can't really say mu1 not equal mu2 not equal mu3 because we don't know they're all different. It could just be one pair of them being different. That's why we don't write them all there. So those are some of the basic tests. The ones that I would say 95% of zoo school students have done over the years is one of those 3 tests. There are other tests involving proportions and categorical variables, things that aren't really numbers. If you think that that's one that your study you feel really has to be and it won't fit into one of these, of course let me know, and we'll either talk about how can we make it fit one of the other 2, or do we have to use another test, because there are lots of them out there. So hopefully this is helpful, helps you start to make your slide, write your chapter 2, and we'll talk to you about all your studies coming up soon.